This is a summary of P6h, which is the last part of the P6 module, which is on charging. So this topic covers two basic electrical components, which are diodes and capacitors, and how they are used in rectifier circuits. Now, the purpose of this is how do we go from an electrical circuit which has got an alternating current or an AC power supply input. So on a voltage time graph, an AC input would be a sine wave, like that. Now, some electrical components have to have DC or direct current as their power supply. Now, a DC power output on a voltage time graph would just be a straight line. So remember, DC, direct current, means that the current only flows in one direction, so it constantly goes as a flat line. Whereas AC, the current is constantly changing direction, which is why it goes from positive to negative. So the sort of purpose of this topic is how do we go from there to there in a circuit. So the component that we use for that is a diode. So you should remember that a diode only allows current to flow in one direction through the circuit. That's the circuit symbol. Another type of diode that you should be familiar with is an LED. Just remember that is also a diode. And then the other circuit symbol that I'm going to use in this is a capacitor, because what a capacitor does is stores charge and stores electrical energy for a short period of time before discharging. So the way a diode works is that it's made of two types of material, two semiconductors. And a semiconductor is a material somewhere between a conductor and an insulator. Now there are two types, an N-type semiconductor and a P-type semiconductor. An N-type semiconductor, the N stands for negative, because an N-type semiconductor has an excess of electrons. And a P-type semiconductor has a deficiency of electrons, it has a shortage, and therefore you are left with positive holes. Now, when you put these two semiconductors together, there is a gap between them. And if I connect up my diode so that the positive terminal is connected to the N-type semiconductor, what happens is that this gap widens. And so the electrons can't jump across this gap and can't flow as a current. If I flip the polarity, so if I connect it negative here, so negative to the N-type and positive to the P-type, then what happens then is the gap narrows, and so the electrons are free to jump across this gap. So if I have a diode that allows current through, so if that's my diode, the current will be allowed in that direction, we can describe it as forward bias. And if a diode doesn't allow current through, we describe it as reverse bias. So that's how a diode is made up of two semiconductors. The other thing that we have in a basic circuit with a diode is we always use a resistor to protect the diode. So the first thing we'll think about is if I've got a circuit with an AC input, and I will have a resistor, and I will have a diode, and then I'll think about my output. Okay. Now my input would be AC, so it's going to be our sine curve like this. But because it goes through the diode will not allow the current here in the negative direction. And so what will happen, my output signal will now look like this, which is what we describe as a half rectified circuit. And that's when you have one diode in a circuit. And the reason for that, like we said, is because it can't flow in the negative direction. Now that clearly is only part way towards this. We've got quite a lot more left to do before we can turn this into a DC output. So that's what happens when I have one diode. What we've got to do to get to this point is we've got to use multiple diodes in conjunction with each other. So we use what is called a bridge circuit. So I have a alternating current power supply, and it's connected to a bridge circuit. Now, a bridge circuit is a circuit that consists of 4 diodes. So I have my diodes connected like this. I'm going to complete this part of the circuit first. Like so. And on this diagram you can imagine the two inputs are coming into the top and the bottom of this square, and the outputs are on the sides. So I'm going to connect this first of all to a resistor, or it could be a bulb or some output in the circuit, and it's going to be connected like so. This little jump means that these two wires aren't connected, they're just on top of each other. So what happens in a bridge circuit is, if you imagine I was to look at the input of this, it would be our AC, because this is AC, it would be our typical AC curve. Now what we do is we are interested in the output over here. So if you imagine my circuit at the moment, if I did a voltage time graph of my input, we know that it would look like that, okay? So what we do is, first of all, if we make this positive and this negative, so we deal with the positive half of this cycle, so this side is positive, this side is negative, what will happen is the current will flow around the circuit from positive to negative and will come in at this junction. And then here, it can't go through this diode because that's reverse bias, so it will go through this diode, and it can't go backwards there. It will then flow through our resistor. Now as it goes through the diode and the resistor, it will lose some energy, and so there will be a potential difference or a voltage drop between the two. And so effectively, because it's going from positive to negative, this side of the diode will be positive, this side of the diode will be negative, sorry, the resistor, sorry, not the diode, and then it will carry on around the circuit to this point. Now when it gets here, it might look like it can go through both diodes, but it can't because of this energy drop that we've just described. There's a difference in energy between these 2 points. So the rule is very simple. It never goes back to where it started. So it goes through this diode and then goes back round like that. So that would be for the positive half of our cycle. So if I was to measure the voltage across this resistor, it would be positive to negative, but it would just be slightly less, simply because there is a voltage drop because it's gone through these two components. Now, the way that the rectifier circuit works is that we add, when we do the negative half of this cycle, so I now make this negative and this positive, so the current now will go this direction around the circuit and will come in at this point, okay? It can't go back through there, so it will go through this diode, through the resistor, round, we'll come back to this point. And remember the rule, it can't go back to where it started, so it will go through this diode, back, and then back into the battery, okay? So a slightly different path. The point, though, is that it still goes through the resistor the same way. It's still going to have the same voltage drop, positive to negative. So because this end of the resistor is still positive, my cycle, it will still be slightly less because there's a voltage drop, but it will be in the positive part of my graph. And so what happens, this circuit, we now, if I continue this, will look like so, and we describe this as a fully rectified circuit, or output or signal. Now that still isn't quite our DC output, so we have to have one more component in this, which is where the capacitor comes in. So we connect our capacitor across our resistor, and what happens is the capacitor will get charged up by the voltage input here, the voltage peak. So as the voltage increases across both the resistor and the capacitor together, the capacitor will get charged up. So it will get charged up, and then at this point it will then start to discharge. When it reaches the next voltage peak, it will then get charged up again, and then discharge. And this cycle will repeat itself. And this happens so quickly, over such a short period of time, that to all intents and purposes, even though the line's going slightly up and slightly down, you now end up with what is practically a straight line. So we've gone from our AC input to our DC output. This process of going from a fully rectified circuit to a flat DC output is called smoothing, because we're smoothing the line along the top, and that is the job of the capacitor. The capacitor is used to smooth the circuit, or a circuit output. So key things within this topic: you need to know that a diode only lets current go through in one direction, and if it's used in a circuit on its own with an AC input, it will produce a half rectified circuit. If we use a bridge circuit which contains 4 diodes, a bridge circuit will produce a fully rectified circuit, and then we use a capacitor to smooth that fully rectified circuit into a DC output. When we use a diode on its own, we use a resistor with it so to limit the current that goes through the diode so that it doesn't become damaged. And finally, you need to know what a diode consists of. So it's made of semiconductor material. There's 2 types, N-type and P-type. N-type has an excess of electrons, therefore is negative. P-type has a deficiency of electrons and therefore is positive.